Hello friends, today we are going to discuss static structural analysis of a plate which is having two holes at the left side and right hand side is having one semicircular portion and inside it is having a circular hole. The left side will be fixed and right side you have to apply a pressure of 50 megapascal and we have to see whether the object is failing or not and at which point or at which node the stress value is maximum, that to be checked. This is a very simple or basic analysis which can be done using any other programs or any other softwares, but we will be doing this analysis using ANSYS Mechanical APDL. Generally what is done is modeling any object in any other programs or any other software, then importing that object in ANSYS while saving in IGS format. Now here itself we'll draw the object in ANSYS Mechanical APDL itself and analyze, right? Okay, then let's get started. First of all, we have to open a folder in the desktop where we have to save all this work. Let's open a folder in the desktop by the name of ANSYS. We will save every work in this folder itself, right? Okay. Next part is file change directory, and go back to the folder what we have created just now by the name of ANSYS. All work will be saved there, right? Next part is you have to change the title of this work. File change title. We should provide the name of this title, anything we can provide, but let's provide the name as plate. Okay, and what we have given the name that can be seen in the screen also by plot replot. It will show in the lower left corner the name of the title, plate. Okay, next part we will start from preferences. Preferences is static structural analysis, so structural analysis clicked on. Next part is preprocessor, element type, add, edit, delete. So nothing is defined, you have to add it, add the element. What type of element it will be? Let's take solid element, and by default it is taking quad 4 node 182 and element type reference number is 1. Okay, this is taken. Now this problem we are trying to solve this one as a plane stress problem. In plane stress problem we have to provide thickness. It will be considered as 3D problem, will be considered as a 2D problem. So options, plane stress with thickness. Okay, closed. Now thickness to be provided from the real constants. Add, edit, delete, adding. Okay, and you can see here again the real constant set number is 1 and thickness is asking, let's say the thickness is equal to 20 milli. Okay, done, close it. Next part is material properties. We are using ASTM A36 steel, so which will be having modulus of elasticity 2E5, that is 2 multiplied 10 to the power 5 Newton per millimeter square, and Poisson's ratio 0.26. So material models: structural, linear, elastic, isotropics. Isotropic means material property will not change in any directions, whatever may be, right? Ex equal to 2E5 and Poisson's ratio 0.26. Okay, done. Next part is we have to go for modeling. Modeling, create areas, because we are considering this one as a plane stress problem, so 3D will be converted into a 2D. Let's see the drawing, original drawing, what it is saying. It is length 175, so we have to make a rectangle of length 175 and height 150, 175 by 150. So we are starting a rectangle by two corners. Now here the thing is x and y are origins 0 0, so we no need of providing, it will take by default 0 0. Width is 175 and height is 150. Okay, rectangle is done. Then let's see the drawing again. Right hand side we have to draw a circle of radius 75 mm, and left hand side also we have to draw two circles of radius 25. 75 and 25 radius you have to draw. Okay. Next part is you have to draw again areas, but it will be circular areas. So circle, solid circle. Now the location of the center is required. Center of the circle will be here, right? So x location will be from here to here is 175 and y equal to 75, because this total height is 150, so here will be 75. Location is 175 and y will be 75 and radius is 75. Apply. First one is done. Now again left part we have to do two cycles. One cycle will be here and another cycle will be here, right? Let's see the drawing again. So this is the starting point origin. We have to go back to this position, and here you have to draw this circle of radius 25, right? Okay. So again doing a circle. Location is here, so it will be x equal to 0 and y equal to 25. Radius is 25. Apply. First one is done. Second one we have to start from here, right? Let's see the drawing again. We start the circle here, so we have to move from here to here equal to total length equal to 150 minus 25. This is 125. X equal to 0, y equal to 125. X equal to 0, y equal to 125. Radius is 25. Okay, two circles drawn. Now next part is here you have to draw one rectangle. See the drawing again. Two circles drawn. So we have to make a rectangle from this location, this point. It will be a rectangle like that, right? So rectangles starting point will be here. That means from origin was here, that position location 0 0. So you have to move back minus 25. Then y also 25. And width is 25, height will be 100, because 100 will be 150 minus 50, 25, 25. We are drawing a rectangle. Next one, rectangle by two corner points. X will be minus 25, y will be 25, width 25, height 100. Okay, drawn. Now all these are separate entities, separate areas. All these areas to be converted into a single area. How can be done? This one can be done using operate, booleans, add areas. Now pick all. Okay, it is a single entity. Now single area is formed. Next part is you have to make again some concentric, some other area to be subtracted. See here at this location one circle should be subtracted, and left side two circles to be subtracted. The location is very important. Location for the first circle is from origin 175, 75, and radius is, diameter is 75, so radius will be 37.5. So again create areas, circle, solid circle, x equal to 175, y equal to 75, radius is 37.5. Apply. First one is done. Second two circles you have to put here and here of radius 12.5. Again, so first location x equal to 0, you have to move the circle here, x equal to 0, y equal to 25, radius is 12.5. Apply. First part is done. Second you have to do here again, x equal to 0, y equal to 125, and radius is 12.5. Okay, now this circular portion we have to subtract it using operators boolean subtract. Operate booleans subtract areas. Now here the important thing is, while subtracting an area, first of all we have to select all areas. Pink color means all is selected. All is selected, then OK. Next part is which part you will select, that one will be cancelled out or will be rejected out. Now next we are selecting this one, this circle and this circle. OK. This part will be rejected out. So this is the original drawing, right? Fine. Next part is we have to create nodes. So meshing is required. We have to go for meshing. Now different type of meshing options are available. Better to control the mesh using manually. So meshing starting. Mesh tool is there, that means automatically meshing will be created, but we prefer size controls. Size controls, manual size, areas, all areas. Now it is asking size element, edge length. Let's the edge length is providing 5 mm. Okay. Fine. Now next mesh it. Mesh areas, free, pick all. Meshing is done, right? Complete. Next part is you have to apply boundary conditions. That means left part should be fixed, that is these holes to be fixed, and right side some pressure of 50 megapascal should be applied. Okay. So solution. Now we are starting loads. Analysis tab, new analysis. It is static structural analysis. Then defining load. Apply structural displacement on lines, because the thing is here these holes are actually the lines, because it is providing thickness in the back side, but it is a plane stress problem. So displacement on lines we are fixing. Select the lines. It will be 4 lines, 4 quadrants actually. 4 lines. Apply. All degrees of freedom and displacement is 0. We are not providing any value, that means by default value it is 0. Apply. This is fixed. Again you have to select this one. 4 lines. Okay. All degrees of freedom, 0 values. Okay. So these 2 holes are fixed. Next part is you have to apply pressure on the right side. Pressure on lines again. We select 4 lines. 2, 3, 4. Okay. How much pressure should be applied? 50 megapascal. Okay. So arrows are pointing outwards. It is showing pressure is applied from inside to outside. It is done. Next part is you have to solve this. You have to solve it. Solution. Solve. Current tells. If everything is right, it will show solution is done. Solution is done. So perfect. Everything is done. Now let us see the results. Right. Before seeing the results, actually we want to say that ANSYS or any type of this type of softwares are trying to get the perfect answer. We don't know whether the result what we are getting is perfect or not. To get the perfect results, we have to go on meshing again and again. At different meshings, we can see different results will be obtained. Now, at which meshing, if the result is not changing, then we can see that we can say the convergence criteria is achieved. That means further meshing is not providing any change of results. Now, first of all, we are changing. We are seeing at 5 mm length meshing size. What is the value of stress? Next part we will change the mesh size. Right? Okay. So what we will do? We'll check the stress values, and other displacement we will not see later on. First we want to check the stress values. It will be seen from general post processing. Plotting results can be done, listing also can be done. As this is not the final answer, so we want to see the listing only the numbers we want to see. List results, stress, then nodal solution, stress, one measure stress. Okay, it is showing the stress value is equal to 120 at node number 168. This one we have to remember. Stress value is equal to 120 megapascal at node number 168, right? 168 node number. This part we can save it for comparison. File save as. The node number is 168 and stress value is 120, that we checked. Now this is obtained with a specific mesh size. Next what we will do, with different mesh size, we will see how much the answer is varying. So we have to go back. What to do? Plot elements. We have gone back to the previous one. Next what to do? We have to change the mesh size. Preprocessor, modeling, meshing, modify mesh, refine at all. We're refining the mesh size. See, mesh size is refined. Now we'll do the analysis again with applying different loads. The same load, analysis type, new analysis, static structural analysis, define load, apply structural displacement on lines, fix this line, this line, this line, this line, this. Okay. So all degrees of freedom with zero displacement. Okay, these two holes are fixed. Right now we have to apply pressure on the right side. So apply pressure on lines. 4 lines will be there. That's 4 quadrants. Okay, the value of pressure is equal to 50 megapascal. Okay, pressure is applied. Now we have to run this one. Solution: solve, current tell us. Okay, solution is done, everything is perfect. We'll see the value of stress generated. General post processing, list results, nodal solution, stress, one with stress, apply. See the value of stress, it is 122 at node number 169. 122, before it was 120 something, right? It's changing a little bit. Next one, let's see. Before it was 120 something, now is 120, little changing with mesh size. Next one we'll check. Again we have to remesh it, right? So plot elements, preprocessor, meshing, modify mesh at, refine mesh at all. Okay, this meshing is fine, meshing is completed. So it is very fine meshing, as you can see. Now again we have to apply boundary conditions. So load, analysis type, new analysis, static structural analysis, define load, apply structural displacement on lines, fix the lines, okay, the lines are fixed, all degrees of freedom with zero displacement, the lines are fixed. Now we have to apply pressure on the right side circle, apply pressure, apply structural pressure on lines. Select the lines, 4 lines on the circle, in a circle. Okay, pressure is 50 megapascal applied. Next part you have to solve it. Solution, current LS, okay, solution is done. Let's see the answer. General processing, least results, nodal solution, stress, 1 measure stress, okay. Let's see the answer. It's 123.82. Before it is 122. So the value of stress is changing. Very small amount of change is visible with further modification of mesh. So we can finalize this is the final stress, because this is final. The mesh size is very small. It is very fine meshing is created and the stress value changing is very small, right? Or we can do further modification, further refining of the mesh and check how much it is, but I think it is modified. The answer is convergence criteria is achieved. Okay, so the stress value equal to 123.82 and at node number 169. Now our task is to see at which point or which location stress value is this much, 123, at which location. Now we can see this value of stress is very less compared to the yield strength. Yield strength is 250 megapascal for this material, and the maximum stress developed equal to 123.82, which is much below the yield strength. So design is safe, and also factor of safety is near about 2. Factor of safety equal to yield stress by working stress 250 divided by 123. So it is near about 2. The design is safe and good enough, right? Now our task is to see at which location the stress value is this much, 123.82. That location we have to see. Okay, this is the answer. We will save it. File, save as, right? Node number is 169, that will be remembered. Node number 169, right? Now we'll see plot, controls, numbering, node numbers is off, that we made on, okay. Then plot nodes, the nodes is already created. Now we can guess at any specific location the stress value will be high. Maybe here, or that corner points. We will check here from plot controls, pan zoom, rotate, box zoom. Let's see this one at 168, this one. So this point is having maximum stress, 168 node number. We have seen at this point we are having maximum stress. This is the answer, right? So our task is obtained. Okay, fix it, fit it, close. So this is all about our finite element analysis of a plate. Here we found the location where the maximum stress is generated by the application of pressure. By putting left side fixed and applying a pressure of 50 megapascal on the right hand side, stress is generated, and the stress is much below the yield stress. The design is safe, and the location of stress we have determined. Okay, thank you for watching this one.